So I'm here in our living room, and we recently purchased a reclining sofa set for the living room here, and this is where we watch our movies. The problem is we can't access the window behind the sofa anymore unless we want to pull end tables out or pull the chair out. And every time we want to pull the shade, the blackout shade down to darken the room for the shade for a movie or a show, it becomes quite a project, and we have to either pull the couch out or step on the sofa to reach the shade, which is up top there. So our previous sofa had got damaged from us stepping on the seats, so we're trying not to do that this time, and we're going to come up with a better solution to try and automate this process where we can have the shade come down. I'm thinking that we could possibly tie it into the Amazon Echo, and so we just come out here and say movie time, and it should darken out. Alright, so I'm taking a look at the mechanics of the shade here, and I'm just trying to get a game plan for what I plan to do. I think this side here is the idle side, and it has a pin that goes into a bracket, just a needle, like a little pin, a spring-loaded pin that goes into this bracket on this window frame. And this just rolls around as the shade comes down. The other side of the shade has a flat on it with a spring inside the tube, and that is what helps the assist of the shade going up and down. We're not going to have that anymore because we're going to rely on a gear motor here that's going to drive this side of the shade. So the other side has to be disabled somehow. So I'm thinking that I'm going to have to make a bearing with a flat in the center of it so that the spring can rotate freely without binding up the shade. And then on this side put a stepper motor, geared stepper motor on this side to drive this other portion.
Alright, so I'm here in SolidWorks, and this is my first attempt at drawing up this prototype. And what we have is a 28 BYJ-48 5-volt DC motor, actually a stepper motor, and it's just got a few gears mounted on this plate, and this side here has a bearing on it. This is the side that is going to be driving the shade, and this little conical piece here is going to be inserted into that cardboard if it's not too rounded out from being wobbly over the years. I might have to adapt or build up this material a bit so it makes it snug in there. But I think this should work fine since this is a bearing here and the motor here. The reason why I had to make it a few gears is trying to keep the size down, and the window window frame is probably ends right about here, so I couldn't put the motor too close or else I would not be able to mount this plate flat. So I think this is going to work. This should rotate. I don't have any of the gears animated, so they'll go into each other. I don't have that portion fixed in there yet either. But I think this should work out fine. If not, we'll see what we have to do to change things.
Alright, so I'm down here with the printer. Some of the parts are finished. I have to put this cover on here because it's kind of cold down here, and if you don't do this, I don't have an enclosure for the printer, so the parts sometimes warp. But I also use an extra little excessive brim to make sure nothing warps, but yeah, the parts look fairly decent. Let's see if I can get them off here. It's going to take a little bit, but I have these brims on here, so the gear teeth wouldn't come up on the build plate. And this is PET G, it's not nylon. So if this works out, I'll probably end up printing nylon. But this is just a test. Probably have to clean these teeth out a bit, but it's coming off fairly decent.
So I'm going to start assembling the bearing plate here for the left side. So this should just fit right in here. I put a little bit of a fillet on the edge here, so it should lead this bearing in there without too much struggle. And with any luck, I won't have to bang it in there or anything. And it just presses right down in there. Alright, so that part's done. So the left side, actually there's one more piece. This is with a slot of the shade on the left side. gets put in. So let's see if we can get that in there. That's a nice fit. So this should be the non-driven, this will be the non-driven side of the shade. And this is the spring side, so this is going to, the spring is still going to remain inside the shade. This is just going to basically rotate without any function at all, without kind of leaving the shade untouched and unmutilated, because that side is crimped on and I don't feel like taking that all apart and cutting it up. Since the other side is not crimped on, that'll be our driven side. So now it's time to move on to the actual driven side. Okay, so this is the driven side plate, and we're going to start populating this with all the parts. I guess first I'll put the motor in here, and that fits in there really, really nice. I mean, barely any rotational play. If you can see inside the hole there, it's really nice. So that's going to be good if the screws ever did become loose, but I don't think it's going to. Let's see what I get for hardware. I'm just going to use some, I believe, M6 hardware. And let's insert the nuts in here. Hopefully this works out here. I did have to take an edge off here because it was wasn't able to get the geometry without losing that edge, without the holes lining up. This one's being a little fussy getting in there. There we go. Alright, so I got the two nuts in there. Hopefully I can put the motor in without interference of those nuts. Okay, and I should be able to put these in there and start tightening this up. And what do I got for wrenches here? Looks good. You don't need to kill this. There we go. Looks good. And yeah, that's perfect. Now I haven't decided, I have the wires routed on the outside, but it does have a slot I have put in here in case I want to make my electronics on the back side. I haven't decided yet. This is just a prototyping plate just to prove the concept, and once I can prove everything works, I'll make a version 2. So it's time to put the, I think I'm going to put the idler gear on first, or the intermediate gear. This basically just sits on there and this is the driven gear, and this is the final cog that's going to drive the shade. And this is all still a 1-to-1 ratio across the board here. The gear motor here is, I believe is 64 to 1, 1 to 64. So even though you're getting one rotation here, you're still getting one rotation here because these gears are all the same size. They're not anything different. The only reason why I had to make this, I can't just drive this final gear, is because of the space constraints, and I wouldn't be able to get the motor plate close enough to the actual shade with the wall here, well, the window frame. So I've kind of had to make this little intermediate gear in the middle here. I could have used a bearing in here, but I didn't have anything lying around, so I just kind of improvised and made this post here slightly longer than this is wide. So once I put the cap piece on here, it will retain the gear but not cause any friction against it. Okay, so now I can put the screw through the plastic washer piece I have, and put that in. It should. I'm putting good pressure on this, and we're not getting any friction any more than it was before, so that's good. See if I can get this nut in here. Hopefully this fits in. Might have to press it. Oh, no. Seems like it's going in. You get used to your printer's dimensions after a while, and the shrinkage of the particular plastic you're using, and you start getting good at dimensions that fit. Every once in a while I'll get something that doesn't line up and I'll have to go tweak apart, but everything seems to be going together fairly smooth here. Maybe this, oh, maybe that tool is not big enough to rotate that screw. Oh, here we go. All right, so that looks good. And there's barely any movement in the gear. Just a very slight bit, not much. So that's the best as we're going to get without actually having a bearing in there. I guess the next step would be to put the bearing in here before. Hopefully I can still get it in here with this gear on. I think I should be able to. Okay, let's put the gear. Yeah, no problem. I want to line this up straight. I don't want to press this in at an angle. So let's see if this goes in here. Wow, that is perfect. That is a perfect tension. And I also put these two holes here that I can drive this bearing out for service, or if I want to upgrade the plate, I won't have any trouble trying to get that bearing out of there, because that'd be pretty complicated to get this bearing out at this point since it's pressed in there. So I did make that option so I can drift the bearing out that way with a punch or something. So now I think I'm going to put the drive gear on here, the motor gear. And this gear has a printed insert, or a printed extruded cut inside here that matches this profile of this shaft. So we should be able to get this on here and mesh the gear at the same time. A nice press fit. And beautiful. That went in there. Great. Alright, so it seems like the geometry is working out very well. And very little slop in the motor here, so this is great. So now we're going to start assembling the shade drive side. Alright, so we need this piece here. This piece is going to insert into the bearing, and there's going to be a screw going through here holding this onto the back of the gear, so this can all get pushed on at the same time. And there's a little down the bottom here, there's a extruded cut. Well, it's been profiled out to receive a washer, a nut. And it looks like I may have miscalculated the size, maybe not. I think I may have used the wrong size nut capture there. Let's see. Yeah, it's the wrong size, but I think this will work for a test. So I'll have to make a note of that to change that when I reprint that gear. And this should be good there. Just might be a little tricky getting this nut started since that doesn't have anything to trap that in there. So I will just put an Allen wrench on top of that for now. And hopefully I can start this screw into that nut. I think what I'll have to do is stick a flat screwdriver in here so it will tighten up. Okay. That's tight. And this will be the final piece that goes in here. So let's hope this meshes up. Okay. A little bit looser than I would like to have seen, but it's not falling out. It's not. I would like a little bit more of a press fit, but I think for the first attempt, this isn't bad. I can work with this. Now I can prototype the electronics on the bench and get a feel for how this is going to work. I can back drive the motor a little bit. So that's it. That's the bearing, the drive side assembly all completed at least a prototype version. So we'll have to try and assemble this onto the shade and do some testing. So I have the stepper motor gear drive assembly wired up to a microcontroller, and it's driving a ULN 2003 stepper driver. Now this is a unipolar motor, which is a 5-wire motor, and these tend to produce very little torque. So I'm not exactly sure if this is going to work out or not, but we'll find out. I think you can convert these to bipolar, and all you have to do is take this blue cap off here, and you can actually cut a trace in here and make them bipolar, and you run them on a standard stepper driver. But let's see how this produces first before we decide to go any other route. I'm going to turn my power supply on, and it's not terrible, but it lacks any kind of torque. And this shade is about 5 feet plus, maybe 5 feet, 6 feet long, and it has a lot of material to roll up, so I don't think this motor is going to work out in this situation, or at least in this configuration. But it proves the concept out, though. So what I think I'll do is, see, this is a 5-volt motor, and I'm driving the ULN 2003 stepper driver with 5 volts. You can get more torque out by increasing the voltage of this motor, but you risk starting to heat up the motor and controller. I believe this can go up to 12 volts because they do make 12-volt versions of this motor. I believe that you can run this driver. I don't think the issue would be with the driver. I think it would be with the motor, most likely. It would start to get warm. But considering that this thing only does 5 rotations or 5.5 rotations to move the shade up and down full length, I don't think that would be too much of an issue. I think if I converted this or increased the voltage, I can get the torque out of it. But I don't know. Let's see. Let's try increasing the voltage a little bit. See, this won't even lift itself up. So it starts to bind. So I'm going to increase the voltage up a little bit. Let's see if I move this up to about 7 volts, let's say. And we'll go back to this. Let's see what that did for us. I can already tell it has a lot more torque, and it will actually now lift the gearbox on its own, under its own weight. So just increasing this to about 7 volts has increased the torque. But like I said, you're going to eventually warm up the motor if this is continuously running, but this is not going to run all that much. It's not going to run all that long. And like I said, there's 2 ways of increasing torque on this, and the way I'm doing it right now is not considered kosher by any means, but you can make this a unipolar motor and drive it with a different driver. But, you know, since this is going to be a very long, a very heavy shade, I think I might end up having to upgrade the motor to a NEMA 17 full boat stepper motor and save these for my little 24-inch shades that are in like my bedrooms and whatnot. Then I can use these and possibly just use them in bipolar mode, or even this mode, which is just a few volts or a couple of volts higher to increase a little bit of torque. I don't think this is going to be any issue. So yeah, so I think what I'm going to do is try and print a version of this with a NEMA 17 motor on here, and I think we might end up having to use a NEMA 17 that has a 5-to-1 gear ratio. When you have a 5-to-1 gear ratio, it means the stepper motor will rotate 5 times versus the output shaft of the gear motor, the stepper motor, that will rotate 1 time. So you increase a lot of torque that way. So yeah, I think I'm going to print up a plate for a NEMA 17 and see how that performs.